Hello everyone, welcome to the demo video for the profit prediction using machine learning project. This is a data science internship project given by Exposys Data Labs. In this video, I'll showcase a demonstration of how this project works and the steps involved in predicting the profitability of startups using ML algorithms. First of all, we need to import the libraries required here. Uh, let's see what are the libraries to be implemented. First of all, I imported pandas. Import pandas as PD. Pandas is a Python library used for data manipulation and analysis. It provides data structures and functions to efficiently handle and analyze structured data primarily in the form of data frames. Now we'll import NumPy as NP. NumPy is a fundamental Python library for numerical computations. It provides support for large multidimensional arrays and matrices along with a large collection of mathematical functions to operate on these arrays. Now coming to Seaborn. Seaborn is a data visualization library built on top of Matplotlib. It provides a high-level interface for creating attractive and informative statistical graphics. Now we import matplotlib.pyplot as PT. Matplotlib is a widely used data visualization library in Python. It provides a comprehensive set of functions for creating a variety of plots including line plots, scatter plots, histograms, and more. Now we need to import a very important library, actually module, that is sklearn. Sklearn is nothing but scikit-learn. In that we have a library called train test split. Train test split is a function from the scikit library used for splitting a dataset into training and testing sets. The function randomly shuffles the data and assigns a specified portion to the training set and remaining portion to the testing set. This is useful for evaluating the performance of machine learning models. Coming to R2 score. R2 score is a metric used to evaluate the performance of a regression model. It ranges from 0 to 1, with a higher value indicating a better fit. Coming to mean absolute error is a metric that calculates the average absolute difference between the predicted and actual values. Coming to mean squared error is a metric that calculates the average square difference between the predicted and actual values. Now we need to import all the important libraries that are required for each model. They are linear regression, random forest regression, decision tree regression, lasso regression, ridge regression, elastic net regression, and SVR regression. SVR is nothing but support vector regression, and XG extreme gradient boost, and TensorFlow for doing neural networks. Here we do feed forward neural networks, and preprocessing. Min-max scaler is a preprocessing technique used to scale numerical features to a specific range, typically between 0 and 1. So first of all, let's do data analysis and visualization. First we preprocess data. First we'll run this. It is running. Wait for it to complete. Meanwhile, we'll see. Here it ran. Now coming to data analysis and visualization, first we need to import the data. We use pandas.readcsv class, and the file name is 50startups.csv uh, to get the data of the CSV file into a data frame of pandas. So we'll do it, and here we got the data. See, in that R&D spend, administration, marketing spend, and profit are there, and this is index. There are totally 50 rows, I think. Yeah, 50 rows. Now we'll get info of this data frame using data.info. Yes, see, these are the columns in the uh, data frame, and these are the data types. Okay, if we want columns in the form of array, we can use like data dot columns. Okay, now the main part comes, the plotting of the data. First, we'll do correlation matrix. Okay, correlation matrix is a type of plotting technique used for between it is used for calculating the specified columns in the data frame. I- the heat map shows the correlation values between the selected variables with higher values represented by warmer colors and lower values by cooler colors. Okay. First of all, let's understand the every term in here. First of all, the variables. This variable stores the correlation matrix calculated using core function. Here, core function is here. See here. Core function. It represents the pairwise correlation between the selected columns from the data frame. Here, this is the data frame we have. Okay, and we use Seaborn, and in Seaborn, heat map is there. Heat map. This function from Seaborn is used to plot a heat map, which is graphical representation of the correlation matrix. Okay, and annote is equal to true. This parameter enables the annotation of the heat map with the correlation values. Cmap is equal to coolwarm is a parameter representing a range of colors from cool to warm. Here we use blue to red. Okay. Now we give a title here correlation matrix and we do plotting. See, we got the plotting. It is compared with the profit and these are all variables. Okay. Now we do scatter plots. Scatter plots we do with pair plot technique. Pair plot, this function from Seaborn is used to plot pairwise relationships in a dataset. And x variables, see here x variables are given a list of column names from the data frame to be used as an x-axis variables in the pair plot. In this case, it includes R&D spend, administration spend, and marketing spend. Y variable contains the feature. So, sorry, this is target variable. Target variable. We have from the data frame, we use y variable as target variable, and it is used as y-axis variable. Okay, kind is equal to scatter. This is the type of plot used for pairwise relationship. This scatter is specified to create a scatter plots. Now let's show the plotting. Show means to display the plot. See, this is the representation of three graphs with respect to profit, R&D spend with respect to profit, administration with respect to profit, marketing spend with respect to profit. Okay. Now we'll do Regression plots contain regression plots are various types. We use LM plot. LM plot is nothing but linear model plot. It is same like scatter plot, but we have a linear regression line passing through the origin, from origin to infinite space. So let's do this. I'll explain LM plot. Like it is plotting a linear regression model, and same it's like scatter plot, but there will be a regression line passing through the origin. Okay, let's see the output. See, this is the same scatter plot, but with respect to linear regression line. See, this is almost predicted, and predicted will be correct for R&D spend. There are more deviations in administration, but R&D spend and marketing spend have less deviations. Okay, coming to this is the technique of linear model plot. Now coming to distribution plot. Okay, distribution plot is a function from Seaborn used to plot an univariate distribution of observations. Like univariate distribution. Univariate distribution means the plot represents the data as a histogram along with a smooth curve KDE plot that estimates the probability density of the observations. See, I'll show you the distribution plot. See, this is the curve. This curve is called smooth curve, which is KDE plot. that estimates the probability density of the observations. Okay. Here we gave color as maroon for the distribution plot. We can give any colors. There are many colors in here. Coming to histogram plot. See, histogram is nothing but is used to plot histogram of observations. Here color is sea green. Here we get a bar plot where the height of each bar represents the frequency or count of observations falling within that particular bin. Okay. Now plotting techniques are over, visualization techniques are over. Now we'll do models training, testing and evaluation. First of all, we give y variable as target variable. See, y is assigned the values from the profit column of the data. This variable represents the dependent variable or target variable. Okay. X is assigned the values of R&D spend, administration, marketing spend. This variable represents the independent variables or features. Okay. These are like by separating the data into X and Y, the code prepares the data for machine learning models, where X contains the features used to make predictions and Y contains the corresponding target variable that the model aims to predict. Typically in machine learning, the goal is to learn a function that maps the features X to the target variable Y, allowing predictions to be made on new unseen data. Okay. Now X train X test, Y train Y test is called train test split, XY test 0.2, random state is equal to 42. Now we'll understand clearly. Train test split. This function is from the sklearn dot model selection we saw earlier. It is used to split the data into random train and test subsets. Now X is you already know the independent variable dataset that was previously defined. The dependent variable Y and test size 0.2 defines that proportion of data that should be allocated for the testing set. In this case, it is set to 0.2, which means 20% of the data will be reserved for testing, while the remaining 80% will be used for training. Okay. Now coming to random state is equal to 42. Here random state is nothing but uh, this parameter sets the random seed value to ensure reproducibility. It ensures that the same random split is obtained each time for the code is executed, which is useful for consistent results in model evaluation. Okay. Now we know all these variables. X train is the training set of independent variables obtained from X. X test the testing set of independent variables. Y train the training set of dependent variables. The training test of the testing set of dependent variables. Okay, obtained from Y. This is obtained from Y, obtained from X, obtained from X. Now first of all we do linear regression. What is linear regression? First of all let's run this. Okay, linear regression. Linear regression is a statistical model that aims to establish a linear relationship between the input variables and the target variable. It predicts the target variable based on the weighted sum of the input variables. Okay. Now coming to linear regression. First we'll create an instance of the linear regression class, which is linear regression model. We have created the instance of the class. Now we'll fit the data. Like this method is called fit. This method is called on the linear regression model to train it using the training data. It takes X train as the independent variable and Y train as the dependent variable. So it will train the data. See it is trained. So we do prediction now. Predict method. See this predict method is called on the trained linear regression model to make predictions on the testing data. It takes X test as the input and returns the predicted values for the dependent variable. Okay. Okay. Now we have predicted and we got some testing and training sets. Let's check the R2 score. R2 score is a metric. This function from sklearn's metric module is used to compute the coefficient of determination, also known as R squared, between the predicted values and the actual values, like linear regression prediction and y-test. It measures the proportion of the variance in the dependent variable that can be explained by the independent variables. The calculated R squared value is stored in the linear regression R2 score value. See this. In this we stored the value. First let's run this. Okay. Now we want to know the value of linear regression R2 score. As I have said, if it is nearer to 1, it is the best value. How much we are getting? 0.9006. Okay, it's good. Okay, now we'll see mean squared error. What is mean squared error? Mean squared error is used to calculate the mean squared error between the predicted values and actual values. It measures the average squared difference between the predicted and actual values. We'll store it in its like same mean squared error as it is, as we said, and we are storing it linear regression MSE. Let's see the value of it. Okay, the more the value, the less the value, it's good. Coming to mean absolute error. Mean absolute error is used to compute the mean absolute error between the predicted values and the actual values. It measures the average absolute difference between the predicted and actual values. Okay, we'll store it in linear regression ME, and the value we got it here. Now let's do random forest regressor. Okay, this is also a machine learning model. Random forest is an ensemble learning method that combines multiple decision trees to make predictions. In regression task, random forest regressor creates a forest of decision trees where each tree predicts the target variable and the final prediction is obtained by averaging the prediction of all the trees. It's the combination of decision trees. You understood, right? Okay. Let's first of all call the random forest regressor, creating an instance of the class, and we'll fit for training the data extrain as independent variable and write as independent variable, as I already said, and it is created, and we'll predict using xtest, which predicts the values for dependent variable. And let's check the R2 score of it. 0.89, 8779.2, 6345. Okay, this is MSC and this is ME. Now coming to decision trees. What are decision trees? We all there are two types: decision tree regressor and decision tree classifier. We use only regressors here because we are doing regressions. Okay, decision tree is a flowchart like tree structure where internal nodes represent feature tests, branches represent the decision rules, and leaf nodes represent the target variable's predicted outcome. Decision tree regressor predicts the target variable based on series of binary splits on the input variables. Okay, hope you understood. Like it will split the data like a tree. You know binary trees and all, right? In the same way, it will split the data. Okay. Let's first create the instance of the class and train the model, and it is created, and we'll predict for dependent variables, and we get the R2 score 0.83 and MSC and ME. Okay. Now let's do lasso regression model. What is lasso regression? Lasso regression is a linear regression technique that performs both variable selection and regularization. It adds a penalty term to the least square subjective function, which encourages the model to select only a subset of relevant features by imposing a constraint on the absolute size of the coefficients. Okay, it's same like linear regression, but we use another parameters like alpha. See, first we declared lasso of alpha is equal to 0.1. First, we create an instance of lasso class, which is a linear regression model with L1 regularization. The alpha parameters is set to 0.1, which controls the strength of regularization. Okay, strength of regularization and all, it's a different concept, and we should explain it mathematically. Now it's not possible. Now we'll fit for training the data, and it's trained, and we'll have the prediction for dependent variable, and we get R2 score 0.9006 and MSC and ME. Ridge regression is also same like lasso, but it's different. Coming to ridge regression is a linear regression technique that also performs regularization. It adds a penalty term to the least square subjective function, which helps in reducing the impact of multicollinearity, high correlation between input variables. by shrinking the coefficients towards zero. Okay. Uh, let's. It also have same like lasso. Alpha is equal to 0.1. Here, uh, this creates an instance of the ridge class first, which is a linear regression model with L2 regularization. The alpha parameter is set to 0.1, which controls the strength of regularization. We saw lasso L1 regularization. In ridge, it is L2 regularization. Okay, and then next we fit for training the data and prediction for dependent variables and R2 score and MSE and MAE. Okay, coming to elastic net regression. Elastic net regression is nothing but combination of lasso and ridge regression. It will have like a ratio of lasso and ridge. I'll explain. Elastic net regression is a combination of lasso and ridge regressions. It adds both L1 and L2 regularization terms to the objective function, allowing it to select features and handle multicollinearity simultaneously. Okay. Let's see what's elastic net. See, first of all, we declare the same like alpha is equal to 0.1. First, we'll create an instance of the elastic net regression model. Combination of L1 and L2 regularization, we know that. Alpha parameter controls the overall strength of regularization, and the L1 ratio parameter determines the mix of L1 and L2 penalties, like lasso and regression. It determines the mix of L1 and L2 penalties. It's given as 0.5, and we gave alpha values 0.1, which is strength of regularization. And then next, we fit and train the data, and we get prediction values and R2 score and MSC and MAE. Now we use support vector regression. Support vector regression is also a machine learning model. It's generally used in classification models, but in regression also there is a support vector regression. It is a regression technique based on SVMs. SVMs are support vector machines. It aims to find a hyperplane that maximizes the margin around the training data while minimizing the prediction error. SVR uses support vectors, a subset of training samples, to construct the regression model. Okay. Now let's understand about SVR. Let's do the practical thing. First, we give the kernel is equal to linear. First, we create an instance of same like all the models, instance of SVR class, and the kernel parameter is set to linear. See, this is the kernel parameter. There are other kernels also like polynomial and all. Linear kernel is indicating that a linear kernel function is used. We use linear kernel function because it's an up. Okay. Now we'll fit it. It will take some time because it's a different type of model and it uses hyperplane that maximizes the margin. Okay, so fitting and training takes time. Let's wait for it. We know X train has independent variables and Y train has dependent variables. Okay, after it trains we'll predict the values for dependent variable, that is what are the dependent variables X Y testings, but we take input as independent variable X test. Okay, let's wait for the SVR to fit and train the data for both independent and dependent variables. Okay, now it is trained. We'll do the prediction here, and it is predicted for dependent variables. And let's see R2 score 0.87, MSE and MAE. Now going to XGBoost. XGBoost is extreme gradient boosting. It is an optimized gradient boosting framework that uses an ensemble of decision trees. It is known for its efficiency and performance. XGBoost sequentially builds decision trees and combines them to make accurate predictions by minimizing a loss function. here a new term comes, loss function. Okay, first of all, let's create the instance of the class, and we have trained the model, and let's do predictions for dependent variable and R2 score, MSC and MAE. Okay, this is XGBoost. It is a ensemble of decision trees. Okay. Next we'll go. Here also we have XGB regressor and XGB classifier. We use XGB regressor. Now coming to main thing, we are using neural networks, feed forward neural networks. Feed forward neural networks are artificial neural networks where information flows in one direction, from the input layer to the output layer. They consist of multiple layers of interconnected nodes, like neurons in the brain, that process input data. FNNs are commonly used for various machine learning tasks, including now we are using regression, right? By adjusting the weights between neurons to learn complex patterns and make predictions. But sometimes it is not accurate because it needs more and more data and less variations. It sometimes gives errors also. First we declare min-max scalar min-max scalar function. First we create the instance of it. It is from preprocessing model of SKLL. It is used to scale the features in the training and testing data to a specific range, typically between 0 and 1. Now we use scalar.fit transform. Fit transform. This method is called on the scalar object to compute the scaling parameters and apply the scaling transformation to the training data, like xtrain. It returns the scale training data. Okay. Now scalar.transform xtest. This method is called on the scalar object to apply the scaling transformation to the testing data xtest. It returns the scale testing data. Okay. Let's run this. Okay. Now TensorFlow, we use TensorFlow to do neural networks models, and Keras. Keras is also API of TensorFlow. First we create the instance of sequential class from TensorFlow's Keras API. It represents a linear stack of layers for building the neural network model. Now coming to dense 32 activation is equal to ReLU input shape and all. First understand clearly what is dense. This represents the fully connected layer in the neural network. Okay. Next, activation is equal to ReLU. ReLU is an rectified linear unit activation function. This specifies the activation function is to be used for the hidden layers. Next, input shape. Input shape is nothing but this defines the shape of the input layer based on the number of features in the scale training data. Okay. Now we'll declare more layers and the final layer, which is one dense layer, and three layers are declared, and each layer have 32, and this is rectified linear unit and shape. Okay, you understood, right? Now we'll run it. FNN model is created. We'll compile it. Compile means this method is called on the FNN model to configure the learning process of the neural network. Here two terms are very important, optimizer and loss. There are many types in optimizers. We use Adam function. This is an algorithm, optimizer algorithm. It is to be used during training. We use Adam optimizer for training here. Okay. Mean squared error loss. This specifies the loss function to be used during training. In this case, the mean squared error is used as the loss function. Okay. Okay, let's fit and train the data for scale. Okay. Here fit, we already know this method is called on the FNN model to train the neural network model. Okay. Extrain scale. This is the input training data. We have scaled. Here we use the extrain scale, right? So we train using extrain scale. Why? This is the target training data dependent variable. Here approaches means this specifies the number of training approaches, like iterations for which the model will be trained. Here we use 10 iterations. See, 10 iterations, right? Here 10 iterations are there, and each step loss and accuracy is calculated. See, this is the way 10 iterations are run, and batch size is equal to 32. It specifies the number of samples per gradient update. Okay. It's very important. 32. We can give any value 64 and all. I gave 32. Number of samples per gradient update. Okay, here 32 samples are taken for each gradient update. Okay. Next, we'll, as usual, prediction for scale testing data. Here use scale testing data. Okay, it has been done. And R2 score. Here R2 score is very worse. Like -11 is, it's like worst of the worst. It's not the best model to use. MAC is good and MAE is also good. Okay, let's uh, get the data in a data frame. We'll store all the values of all the models: linear regression, lasso regression, ridge, elastic net, random forest, decision trees, SVRs, XGBoost, and funnel in a pandas data frame. Okay, let's store it and see. We got all the R2 score and MAE, MSC values of all the models. We used totally 9 models. Okay, now I created a uh, like code for declaring the best model using ranking technique. Okay, here I used what I have used. See, combining all the scores, and which has least, which has best score is declared the best rank. So let's see which is the best model. Here, best model based on total rank is lasso, but it should be random forest. There is I think, let's see. Let's Okay. Now let's see random forest. Here it's coming as lasso. Sometimes it will come lasso and it will come random forest success. But because the model trains differently each time, you cannot say is it trains accordingly same time, same like every time. So we got lasso here. Actually, I have done report and PPT as random forest because at that time it came as best model for random forest. But here it is lasso. Okay, no problem. We can get lasso or random forest, anything. Okay, let's do for lasso as it came lasso. Now let's predict from for random value. Okay, let's enter the R&D spend. Let's keep it 1 lakh. Wait, what are the values? Yeah, it is in lakhs, right? Okay, let's give it 1 lakh, and let's give it 1,50,000, and let's give it 2 lakhs. Okay, the predicted profit of the startup is 1,30,508.73. It may not be right, but according to Lasso regression model, it is approximately right, because what are the values of Lasso? Let's see, 0.900656979 and 8.09 ms. So it may be best, but sometimes you will get the best model as another, because the model does not train every time, same in the same way. Okay, so here we got lasso. Sometimes it will be random forest, sometimes it will be decision tree, sometimes it may be XGBoost. So here it will be lasso. Okay, this is the best model to do the prediction. Okay, uh, now this is the project I have done. Uh, this concludes our demo of the profit prediction using machine learning powered. With the power of machine learning, we can make accurate profit predictions and gain valuable insights into the success of startups. Uh, I have put the GitHub link and all in the repository of the GitHub. Okay, this is the entire project, and from this demo video, lasso regression is declared for this profit prediction as the best model. Thank you. Thank you, Exposys, for this amazing internship project. Thank you.